So after a short gap, let us begin the enrichment classes once again. Regular classes will also start along with these classes. So we have discussed solid state and solution, and in enrichment classes we have been discussing some advanced level problems of the solid state. Because we have solved the simple problems already, the formulas we already know. So now let us discuss on the advanced level problems as we were discussing. Today's problems will be somewhat different from the problems that we have solved already. So let us check the first one for today. I am writing it down, because when I am writing it down, you can also think by yourself what is going to be the answer or what should be the possible way out. So let me write it down. The first one, question is, how many unit cells are there in one gram cube shaped 1 gram cube shaped ideal crystal of AB. Molecular weight has been given as 60, which has a NaCl type lattices. Options are given. Options are not important actually, because we are here to solve the problem, not to pick the options only. So kindly see to it, pause the video, think about it, what could be the possible answer. Now, how to solve this type of problems? These are not the same that we have solved. Question is, how many unit cells are there? How many unit cells? We know that it is a NaCl type structure. NaCl. So if it is NaCl, it should be rock salt type. So obviously rock salt type means it is FCC. So it is Z should be equal to 4. That is the first thing. Molecular weight is also given as 60. Now what can we do is, see, it is 60, which is the molecular weight, into 4. Into 4 because in each unit cell there are 4 atoms, right? So we can say that this many grams will have 6.023 or 022 whatever into 10 to the power 23 number of unit cells, because molecular weight should be multiplied by the number of atoms in an unit cell. So that many amount in gram will have this much amount of unit cell. So here we have to find out in 1 gram cube shape of such crystal how many unit cells will be present. So for 1 gram it should be simply divided by 6.022 into 10 to the power 23 divided by 60 into 4. Now you are supposed to solve it, how much it is. So after the calculation, you will be getting near about 2.5 into 10 to the power 21 unit cells. So that is how we will calculate. Next question for today is like this. Question is, titanium crystallizes in a face-centered cubic lattice. It reacts with carbon or hydrogen interstitially. It reacts with carbon or hydrogen interstitially. By allowing atoms to occupy holes in host lattice, now hydrogen occupies tetrahedral holes, and carbon occupies octahedral holes. Question is, predict the formula of titanium hydride and titanium carbide. So let us see how it is to be solved. So if we look into the question carefully, titanium crystallizes in face-centered cubic. That means titanium crystallizes in FCC. So how many titanium should be there in per unit cell? Titanium should be 4 per unit cell, right? All of us should agree on that because it is FCC already written on the question. Now we know that if n is the number of atoms, so 2n should be number of tetrahedral voids, and accordingly n should be number of octahedral voids. So based on that only we can solve it. How? If titanium, the number of atom in this unit cell is 4, so obviously hydrogen should be how many? Hydrogen will occupy, here it is written, occupies tetrahedral holes. So it should be 2n number. So the number of hydrogen should be 2 into 4, which is 8. And at the same point of time, titanium and hydrogen, they will combine to form titanium hydride. So in case of titanium hydride, formula of the compound should be how much? It should be Ti4H8. But we do not write the formulas like this. So the simplified formula will be TiH2, This is the formula of the titanium hydride. Similarly, if we see the position of the carbon, so the carbon occupies octahedral holes, so it should be 1 into 4, which is 4. So in that case, how many carbon atoms will be there? 4. How many titanium should be there? 4. So if we have to find out the formula of titanium carbide, I think all of you are sure why carbon is 4, because carbon occupies octahedral holes. And if the n number of atoms are present, n should be the number of octahedral voids or the octahedral holes. So the formula here, the formula of the compound should be Ti, 4, because in a unit cell there are 4 titanium atoms, and how many carbon should be there? 4 as well. So the formula should be TiC, because there are 4 of them. Both of them are 4. So these are the two formulas which we have detected. Next question is slightly bigger. So you write down the question along with the video, because I have to utilize more amount of space on the whiteboard. So better you write it down. First the question you write it down. Then what we are going to do is, we are going to shift the videos. So first you write it down. First you write down the question. Then looking at the question, you try to look into the answer. First obviously you try to solve it, write down the necessary data and accordingly. So let us see, let us face it. Question is, as I have said, it's an absolutely different type, definitely advanced level. So it's the third one for today. Volatile compound A crystallizes in FCC manner. Its density in solid state, its density in solid state is 2.3 gram per cc, full stop. Then 25.45 gram of compound A along with 39.6 gram of carbon dioxide at 100 degrees Celsius and 3.2 atmospheric pressure occupy 9.56 liter volume. Calculate the van der Waals constant B for compound A. Now please note that compound A exists in gaseous state at 100 degrees Celsius. So it's an absolutely different type of problem, as I have told you. So how to proceed in this type of problems? So for that, let us see what are the values which are already given, and based on that we are going to propagate. So first thing first, you note everything down. Note down the question, because obviously in this much space I cannot solve the complete amount of the problem, complete portion of the problem. So first you note it down. See what we have to solve. Let us go for the back calculation. We have to solve we have to get the van der Waals constant B. Right? So what is the value of B? The value of B is 4 by 3 pi r cube into, means it should be 4 into 4 by 3 pi r cube, that we have seen in the states of matter chapter in the class 11. Here it should be multiplied with the number of atoms also, Avogadro number, because we have to calculate the van der Waals constant B, and in that case what we have to do is we have to multiply the Avogadro number with the formula of B. So for that, do we have everything? We do not have R. We have to get R because N value we already know. Now how can we get R? To get R, the formula for FCC should be 4R is equal to root over 2 into A, right? So in order to get R, now you have to get A. A is not given. How will you get A? You have to use this formula, Z into M divided by N in A or N0 whatever into A cube. So we can take it over here. We will be using A cube is equal to Z into M divided by Na into D. Density is given, molecular weight is given, and we'll see the rest of the things. Main thing is we have to get A, then only we can get R, and if we get R, then only we can get this small b, which is the van der Waals constant. So is it directly given? Density is obviously given, but we don't know what is the molar mass of the A, compound A, which is not given. So in order to get the molar mass, we need to get the number of moles actually. How many? Now, because here it is given, say, this much of compound A is given. If we know that, say, this much is N mole, so based on the number of moles that is present in this particular case, we can calculate the molecular mass. So first thing first, we will calculate this amount of the compound is how much mole. If it is 0.2, so this much is 0.2. 0 to 0.2 mole is this much. 1 mole is how much. From there we will get the molecular weight. We'll put the value of molecular weight here. We'll get A. Once we get A, we can calculate R. Once we calculate R, we can calculate B. So it's a, you can say it's a long process. Again, I would like to repeat, what are we doing? We have to calculate the van der Waals constant B. I have written the formula. You can check the states of matter chapter, it is there. Actually, the van der Waals constant, calculation of the van der Waals constant is not there in the CBSE format, but the formula is there. You have to use this formula. Now the point is, in order to get B, we have to get R. How to get R directly? The radius of the atom? We have to get the edge length. It is also not given. So how will you get the edge length? From this density formula. So in order to get A, you have to get the M. M is not given in the form here, but density is given though. So we have to get M. How will you get M? For that you have to get the number of moles, as I have said. So this is the total process. So let us now see how can we get the number of moles. So initial part I will solve it here, then I will erase. Here you can see, first of all, for carbon dioxide gas, we know that this formula PV is equal to nRT, right? PV is equal to nRT. So now we can write P of carbon dioxide into volume. How much volume? This much. 9.56 is equal to number of moles of carbon dioxide. How much of carbon dioxide that has been taken? 39.6 gram. So 39.6 gram of carbon dioxide, that is N, divided by the molar mass. Carbon dioxide, as we know, quickly you can calculate, carbon is 12 and it is 2 into 16, that is 32, so that is 44. So it is 44 into, it is given in liter atmosphere, so we have to put that value only. It should be 0.082 into 373. So we have to calculate this. Calculate this. After calculation, you will be getting T of CO2 is equal to 2.88. Now the question is, we have to calculate for A gas, right? Because volatile compound A crystallizes in FCC manner and its density in solid state is given. But what should be the partial pressure of A that is to be calculated? Check here. The total pressure is given. So it is a combination of P total is equal to P of CO2 plus P of A. So P total is, I am erasing this part, P total is 3.2 is equal to P of CO2 we have just calculated, 2.88 plus PA. Now PA should be how much? You will be getting 3.2 minus 2.88 atmospheric pressure. So it is coming as 0.32 atm. So this is PA. Now what we should do is, we have to calculate the number of moles of A. So for that, over here we can write PA into V is equal to nRT. So N should be PA into V by RT. PA, partial pressure of A, we have just calculated 0.32 atm, into volume. Volume is how much? In this case, check, it is 9.56 liter, divided by R. R we are getting in, we know this value already, 0.08. I am not writing the units, you know, the number of moles will be unitless. So N will be obviously in terms of mole. So here T value should be 373, because at 100 degrees Celsius it is said. So here it is, you calculate this much, you will be getting N of A as 0.1 mole. I have previously calculated. So we are getting number of moles of A as 1. And it is equal to, or it is, you can say, number of, if there is 0.1 mole, It is how much of compound? It is 25.45 gram. So obviously if it is 1 mole, it is going to be 254.5 gram, isn't it? I hope all of you have understood this part. So by calculating all this, we have only came to the point that the molecular weight of this particular compound A is 254.5. Now let us proceed. So after getting the molecular mass, we know that density is equal to Z into M divided by N0 into A cube. So A cube should be is equal to Z into M divided by N0 into D should be is equal to, just erasing, 4 into 254.5, which we have just calculated, divided by 6.022 into 10 to the power 23 into density. Density, is it given? Here it is given, 2.3. So we have to calculate this much. Use the calculator just to reduce time, and I am getting as A cube is equal to 735.2 into 10 to the power minus 24. So I need the value of A actually. So A should be 9 into 10 to the power minus 8. Roughly around I can say. So now I have got A. When I have got A, I can calculate the value for R. That is actually I need. So we know 4R is equal to root over 2 into A. So R should be root over 2 by 4 into A. So it should be 3.19 into 10 to the power minus 8 centimeter. So I have got R now. Now finally I have to calculate the value of B. Value of B should be 4 into 4 by 3 into pi to R cube, that is, let me write down the formula first, into Avogadro number. So here it should be 16.3 into, that is pi, which is 3.14 almost, into R cube, that is 3.19 into 10 to the power minus 8 whole cube into 6.022 into 10 to the power 23. See, how will you simplify this? Actually this much becomes 10 to the power minus 24, and this one is 10 to the power minus 10 to the power 23. So accordingly you readjust, okay? I am not going through that process because here we have to solve the problem, not to calculate the huge amount of, by taking the huge amount of time. So I hope all of you can do this part, and you will be getting as 327.26. I have calculated that already. This is the value of the van der Waals constant, because as you can see, the value of van der Waals constant, this will be centimeter cube per mole. It is an amount of volume per mole. So this is the whole story. It's a long problem, big one, obviously of advanced level, because here we are using PV is equal to nRT, the concept of mole, then we are going into the solid states basic formulas, then we are coming back to van der Waals constant once again. So this is a really good problem, complex one for sure. I hope you have understood. You resolve it again and again by looking at it, so that similar problems you can solve.